we're looking at two-way frequency tables, and yesterday we looked at them as like the total number of people, right? We were saying out of the total people that we asked in this class, how many people have an A, right? Now, there's this other thing that two-way frequency tables does really, really well, and it's super cool. It's called conditional probability. And basically, the idea behind conditional probability is that conditional probability is when we're looking for the probability of event B happening, given that A has already happened. Okay, A has already happened. We already know it's done and over with. A is already done. So what's the probability of B happening? Okay, so this is very different than saying, what is the probability of A and B happening? Okay, because then, for example, if we are looking here at this membership club by grade, I could say, what is the probability that if I pick a student at random, I will get a sophomore who is in drama club? That is, what is the probability of A and B happening? Okay, that's the probability of being a sophomore and being in drama club. The difference between that and conditional probability is, given that I pick a sophomore, what is the probability that that person is going to be in drama club? So I'm only looking at the sophomores now. I don't care about anybody else, right? So my total sample space now goes from everybody, all 115 students, down to just the 36 sophomores, because I'm saying, given that I already picked a sophomore, so I know I only have 36 total outcomes now because I only have 36 sophomores in my group. What's the probability that I pick one that went to drama club? Okay, so that's the difference between conditional probability and the intersection or the and in probability that we talked about before. Okay, so let's look at our question. What's the probability that a member of the art club selected at random is a junior? Okay, so I hate it when they don't use the word given, and then I did it for you, but usually your key, ding, 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 that it's conditional probability is they use the word given. Given that I select a member of the art club, what's the probability that they're a junior? Okay, so we can kind of like read it that way. But it's important to understand how to read this because they get presented in this way often. What's the probability that a member of the art club selected at random is a junior? So we're saying I already selected somebody and I know they're from the art club. Okay, I'm only talking about the art club. So if I said, what is the probability of, if I select one student at random, what's the probability that they are in the art club and a junior? I would say, well, that is 16 out of 115 people, right? There's 16 people that are both out of 115 total. But we're not talking about that. We are talking about, given that I've already selected someone from the art club, what's the chance that that person is a junior? And so now I'm not talking about 115 people. I'm talking about 58 people. I don't care about anybody else. I only care about the art club. So what is the probability that I pick someone that's a junior from the art club? That would be 16 out of 58. So the probability of selecting a junior, given that I know the person is in the art club, is 16 out of 58. So the way we write this in statistics is probability of B given A. It's this like line. So if I said the event B is being a junior, and A, the event A is being an art club, then this reads, what is the probability of being a junior given that I know the person is already in the art club? Okay, let's look at some more examples. I have a class of students. Here's the summary table. What is the probability that a student who did not complete the homework passed the test? So this is really conditional and probability. We won't get too much into why it's super important, but it's really important because it helps us see causation and it helps us check to see if things are independent. Because if we see that given that a student didn't do their homework, that passing the test has a different probability than it just happening at random, then we know that not doing your homework could possibly cause not passing the test. Okay. So again, I'm not going to go tons and tons into that, but this is why conditional probability is important. Okay, so what's the probability that a student who did not complete the homework passed the test? So are we talking about all the students here? Are we talking about, let's see, 17 plus 6, so it's 23 students. Are we talking about all 23 students? No, we are only talking about the people who did not complete the homework. So like we literally don't care about any of these people. These are the people who completed the homework. They are not in our sample space. Our sample space is only the people who did not complete the homework. So how many people did not complete homework? 7 did not complete the homework. So those are our sample space. And of those 7, if I picked from those 7, what is the probability that I pick someone who passed the test? Well, the probability to pick someone who passed the test would be 3 of those 7 people passed the test. So it's a 3 in 7 chance that the probability of getting someone who passed the test given that they did not complete the homework. So did not complete the homework would be A, passing the test would be event B, and so the probability of B given A is 3/7. So we have this one example of A has an A, doesn't have an A, female, male. Okay, so again, this is, you have to read these to understand that they're conditional probability, not just regular probability. Okay, so regular probability is we're looking at the whole group of people. Conditional probability is we're only cutting out a slice of the people. We're only looking at people who fit a certain category. Okay, so what's the probability that a female student does not have an A? Okay, so this is not saying what's the probability that I pick a student who is female and does not have an A. This is saying given that I already know the student is female, what's the probability that that student does not have an A? So again, I don't care about male students at all in this. They are not in my sample space. My only people in the sample space are the female students. Okay, so female students are the only people in my sample space. So I'm only looking at this group. So what is the total number of people that are in my sample space? Well, it's 16, right? Because I'm only looking at the females. And of those 16 people, what's the probability that they do not have an A? Well, that would be 10 out of 16. And we could simplify that if we wanted to 5/8. But truly, we could just say 10 out of 16 people, 10 out of 16 females do not have an A.